Hello again, dear students. My name is Masoud. I'm a physics teacher. We are in Ferho's website here to explain the physics curriculum, grade 12. In previous lessons, we answered some questions from chapter review of chapter 1. We answered 28 questions. Right now, we are going to answer question 29, or this is a problem. You have to solve question 29. Let me read the question for you. It says, an airplane is flying in a horizontal circle at a speed of 105 meters per second. So what's this number? This number is tangential velocity of the airplane, right? Of the airplane. It says the 80-kilogram pilot does not want the centripetal acceleration to exceed 7 times free fall acceleration. So what's the, let's say, concept of the question? What do you understand from the question? It says the pilot, this is the mass of the pilot, right? The pilot does not want the centripetal acceleration. It means G. Centripetal acceleration, it means, excuse me, it means AC, right? Centripetal acceleration, AC. It does not want to exceed 7 times free fall acceleration. What does it mean? So pilot tries not to exceed 7G. This is the condition. Pilot tries not to exceed the 7G. What does it mean? Teacher, what do you mean by this? Could you read it mathematically? Yes. So AC is equal to 7G. The pilot does not want to exceed the centripetal acceleration of the plane to exceed 7G. When the centripetal acceleration reaches 7G, it says it's enough. That's it. I'm not gonna, let's say, increase the velocity. So AC becomes 7G. This is the condition. You have to focus on this condition to solve the problem. So given an unknown, what are the given and unknown? VT is equal to 105 meters per second. M is equal to 80 kilogram. AC is equal to 7G. It's very important. You have to concentrate on this condition. And we look for R. It says A, find the minimum radius of the plane's path. We look for R. So which rule works here? Think about the, let's say, rule. Think about the rule of centripetal acceleration. AC is equal to, what's the original rule of centripetal acceleration? VT squared divided by R. And we look for R. Rearrange the equation for R. Put a denominator of 1 for AC. Cross multiply the equation like scissors. So R is equal to anything multiplied by R goes down, goes to the denominator. AC goes down, and VT squared multiplied by 1 goes to the numerator. Here, substitution matters. It's very important. VT squared, no problem. Just, let's say, substitute the value 105 squared divided by AC. AC here, you have to use 7G, right? You have to focus on the condition. AC is equal to 7G. That's it. So, and G is equal to 9.81, right? 105 squared divided by divided by 7 multiplied by 9.81. This is the answer, 160.55 meters, or approximately, you can say R approximately is equal to 161 meters. Approximately, actually, if you encounter this question in national exam, and because national exam questions are all in multiple choices, that's why maybe you see, let's say, 4 options, and some options, sometimes actually options are approximate answer. Actually, they are close to the number, right? During your solution, you don't get the exact number. That's why in this situation, maybe one option is 161 meters. That's why you have to let's say circle the closest answer to your number, right? Let's move on to question 20. Question 30. Question 30 says, oh no, excuse me. This question has another part, part B. Part B of this question, it says, let me read the question for you. The part B, at this radius, so we found radius 160, let's say 160.55 meters, let's say approximately 161 meters. At this radius, what's the net force? So guess let's say, guess the unknown. What do we look for? It says, what's the net force? We look for centripetal force, Fc. What's the net force? That maintains circular motion exerted on the pilot by the seat belt, the friction against the seat, and so forth, right? So it says, what's the net force? We look for net force, actually. We have some information here. M is equal to 80 kilogram. AC is equal to 70. You see the previous condition. You have to apply this condition. It's very important. And we look for F. F is equal to MAC, right? MAC. This is the, let's say, Newton's second law of centripetal force. F is equal to MAC. F is equal to M80, and AC is equal to 7G. And you know what G is. G is equal to 1.81 meter per second square. Multiply 80 by 7 by 9.81 to get this number. Approximately 5,494 Newton. You find this number. I want you to convert this number into the power, into the scientific notation. Let me tell you something. I think I explained it for you. In order to convert the number, any number, into the scientific notation, you have to put a decimal, let's say, point here. Decimal point after one integer number, right? So separate, let's say, one integer number, count one integer number from the beginning, from the left part, and put a point over there. Whenever you put a point here, after the point, after decimal place, actually, the other numbers becomes power, becomes exponent for the number. So I can say 5.49 times 10 to the power 3. Teacher, why do you say 10 to the power 3? Because you put the decimal point here, and after the decimal point, how many figures are there? 1, 2, 3. That's why it becomes 10 to the power 3 Newton. That's it. Question 29 is finished. Question 30. Let me read the question 30 for you. It says, this is question number 30. A car traveling at 30 meters per second. What's this? Tangential velocity. So this is tangential velocity, VT. This is VT, actually. Tangential velocity, VT. A car traveling 30 meters per second undergoes a constant negative acceleration of magnitude 2 meters per second square. So it's negative. You have to put the negative sign in front of the number. When the brakes are applied, when the driver presses the brake, how many revolutions does each tire make before the car comes to stop? What does it mean? Omega final becomes 0, right? Omega final becomes 0. Or here, because the initial information is in translational information, that's why if you, let's say, use V is better, actually. So, is better, and it's easier, actually. Or if you use omega from the beginning, no problem. But you have to convert 30 into the 30 meters per second into the rad per second by means of a radius. But let's say, I used it as it is, without let's say, converting from the beginning. Let me read the, let's keep going. Assuming that the car does not skid and that the tires have radii of zero point 0.3 meters. So VI is present, 80 is unknown, 80 is given. VF is equal to 0 because it says the car eventually comes to rest. It stops. R is equal to 0.3 meters. What do we look for? It says, assuming that the car, how many revolutions? How many revolutions means we look for delta theta in rev. How many revolutions does each tire, let's say, make before the car stops? So, teacher, what's this rule? Delta S is equal to VF squared minus VR squared divided by 280. So this rule, let me tell you a note. I wrote a note for you. Let me read it for you, actually. I've written these notes for you. It says, in circular track, delta X turns to the delta S. In circular track, actually, whenever a car, right, rotates about a circular track, so the distance that is traveled by the car is not, let's say, is not linear. It's not delta X. It's delta S, right? It's delta S, except for the very short time interval. But here it doesn't say very short time interval. That's why I turn delta X to delta S because of the track. And A acceleration is not a normal acceleration because the car circles the square. The car travels along a circular track. That's why acceleration becomes tangential acceleration. Let me read the original form of this rule. This is the original form of this rule, and I'm sure you are familiar with this rule. It's not new rule for us, right? It's the background for us, especially in grade 11. We got information about the kinematic equations in constant acceleration. Vf squared is equal to vi squared plus 2a delta x, if you remember, right? I want you to rearrange the equation for delta x, right? For delta x. I say delta x is equal to, look here, vi squared goes to the left side and becomes negative. That's and goes to the numerator. So vf squared minus vi squared divided by, because delta x is unknown, anything multiplied by the unknown becomes, let's say, a numerator, it becomes a denominator. So in this situation, delta x is equal to vf squared minus vi squared divided by 2a. I told you because there's a circular track. That's why delta x turns to delta s directly. That's why I use delta s here. And because we have a circular track, acceleration is tangential acceleration. That's why I mentioned 80 here. That's it. So it's not a new rule, just I changed some variables here. That's it. Delta x s is equal to 0 squared because it says eventually the car stops, minus initial velocity 30 squared divided by 2. 80 becomes negative 2 meters per second squared. It says negative acceleration, and that's it. So the answer will be positive because numerator and denominator are both negative. That's why they cancel out each other, and the answer will be 225 meters. Teacher, are we done? No. This is delta S. It says how many revolutions, right? So how do you convert delta S into the, let's say, delta theta? How? By means of the first rule of our textbook. Delta theta is equal to delta S over R. Just divide this number by the radius of each tire. So 225 divided by 0.3 becomes this number. So 750 rad. Teacher, are we done? No. Because it says how many revolutions, right? So we have one more step. You have to convert rad into the rev. How to convert rad into the just divide the, let's say, delta theta in rad by 2 pi. Delta theta in rad by 2 pi, 750 divided by 2 pi, approximately 119.4 revolutions. This is the answer, right? Let's move on to another question, question number 31. Let me read question number 31. It says, a coin with a diameter of 2.4 centimeter. Diameter. So there's a coin. This is a coin. Diameter means from edge to edge, from rim to rim. Do we need diameter in our calculation or radius? Guess the answer. Of course, radius. We don't need diameter, but it helps us actually. It helps us to find the radius, and radius is equal to diameter divided by 2. You have to divide the diameter by 2. So 2.4 centimeter, and you have to convert the centimeter into the meter by dividing the number by 100. So anyway, is dropped. It says a coin with a diameter of this number is dropped onto a horizontal surface. The coin is dropped onto a horizontal surface. The coin starts out with an initial angular speed of 18 rad per second. So this is omega initial, right? And rolls in a straight line without slipping. Without slipping, it rolls in a straight line. If the rotation slows with an angular acceleration of magnitude this number. Let me tell you the note here. It says, whenever you hear this word, it says, if the rotation slows, it means acceleration is negative acceleration. You have deceleration. Actually, deceleration is especially used for cars. Actually, here, I don't say deceleration. Whenever you hear the word slows down, actually, for any moving object, it means acceleration is negative, right? Slowing down means negative acceleration. You have to put negative in front of this number, like this. So alpha is negative. Negative 1.9 rad per second squared. How far does the coin roll before comes to rest, right? How far? It says how far. So we look for delta x, because it says coin, after it rolls down, actually it travels and it travels along a linear track, right? Straight line. That's why it's how far does the coin let's say roll before coming to rest. So firstly, I want you to convert diameter into the meter. How do you convert it? Diameter divided by 2 becomes radius, right? But because radius is in centimeter, it's not allowed in SI. You have to multiply it by 10 to the power negative 2 meters or divide it by 100, as you like. So that's it. 2.4 divided by 2. It takes 2 steps. Firstly, divide the number by 2. It becomes 1.2 multiplied by 10 to the power negative 2 meter. Teacher, what's this exponent? Why do we use this? Because let's say dimension is not appropriate. Dimension is not allowed in SI. Centimeter doesn't work in SI. You have to convert it into the meter by multiply the number by 10 to the power negative 2 or divide by 100. So omega initial is given, alpha let's say is present, omega f is equal to 0. We look for delta s, right? Delta s or delta x, right? Because it's so it's how far. I explained it for you, actually. I'll explain for you. It says, firstly, I want you to use this rule. Teacher, what's this rule? Could you read the original form of this rule? Yes, I can write the original form. This is the original form. It's one of the 4, let's say, kinematic equations with constant angular acceleration. Omega final is equal to omega initial final plus to alpha delta theta, right? So I want you to rearrange the equation for delta theta, bring this one into the left side, it becomes negative and goes to the numerator like this, and 2 alpha goes down, goes to the denominator because delta theta is unknown. Delta theta is, let's say, variable. So delta theta is equal, omega final is equal to 0 because it says it comes to rest. Omega initial is given 18 rad per second. You have to square it, divided by 2, and acceleration is negative. I told you, whenever you hear it, the word slows down with the, for example, whatever acceleration, it means acceleration is negative. A slowing down case means negative acceleration. That's why negative cancel out negative. Approximately, let's say delta theta becomes 85.3 rad. Teacher, are we done? No, because it says how far. It doesn't say, for example, let's say what's the angular displacement. It's how far. It talks about the, let's say, linear information. How far does the coin roll before coming to rest? That's why delta S, you have to convert delta theta into delta S by this equation. Delta S is equal to R delta theta. R is equal to 1.2 times 10 to the negative 2 meters. That's the radius of the coin. Multiplied by delta theta, we've already found it. Just substitute it here to find the answer. And the answer will be 1.02 meters. Let's say this is the answer. Maybe you say, teacher, you said we look for delta X, and here we use delta S. In circular track, actually, in circular track, delta X turns to delta S. I told you. In circular track, delta X turns to delta S. So whenever you use delta S or delta X, it doesn't matter, but this is, let's say, nicer. It's more, let's say, appropriate than delta X. That's why delta S is, let's say, more, let's say, appropriate. Let's move on to question 32, right? Question 32. It's a problem as well. It says a mass attached to a 50 centimeter string starts from rest. Let me summarize the information. It says, what's this? The length of a string actually becomes radius, right? Keep in mind that the length of a string becomes radius directly. So R is equal to 50 centimeter, but centimeter is not accepted in SI. You have to convert it to meter by dividing the number by 100. So 50 divided by 100 becomes 0.5 meters. It says starting from rest means omega initial is equal to 0, and it's rotated in a circular track, right? Exactly 40 times. So a mass, let's say, is, I can say, moves along a circular track 40 times, means delta theta becomes 40 cycles, 40 revolutions. 40 times means 40 cycle, 40 revolution, right? Revolutions. And you have to multiply the number by 2 pi in order to get the delta theta in rad, right? So right now, 40 multiplied by 2 pi becomes 80 pi rad. Let's keep on the reading. It says in 1 minute, delta t is equal to 1 minute. Is minute accepted in SI? No, you have to convert it to second. How do you convert minute into second? How many seconds, let's say, are equal to 1 minute actually? How many seconds does 1 minute, let's say, contain? 60 seconds. It says before reaching a final angular speed, what's the angular speed of the mass after 1 minute? What's the angular speed after? It means we look for omega final. So which rule is convenient here? We have delta theta, delta t, omega I 0, and we look for omega. So look for a rule during a let's say, kinematic equation, right? We had 4 kinematic equations. Look for the rule that contains delta t and delta theta, omega I and omega F. So this rule is convenient. Delta theta becomes 1 over 2, right? Omega I plus omega F multiplied by delta t. This rule is convenient. Delta theta becomes 80 pi, right? Because we had 40 revolution is converted to the rad, so it becomes 80 pi divided is equal to 1 over 2. Omega initial is equal to 0. Omega final, we look for it, and delta t is 1 minute, which is equal to 60 seconds. So in this situation, inside the bracket becomes omega f only. 60 divided by 2 becomes 30. So 30 omega f in the right side. And in the left side, we have 80 pi. Omega f becomes 80 pi divided by 30. 0 cancels 0 here. 8 divided by 3.38 rad per second. That's it. Let's move on to question number 33. Right? Question number 33. And actually it has 2 parts. Let's finish this, let's say, this question, and after that, question 33. A 13,500 Newton car traveling at 50 kilometers per hour. So, what's our information here? What's this number? This is the weight of a car. Weight of a car is present, Fg. What's this? 50 kilometers per hour. This is tangential velocity, but it's given in kilometers per hour. You have to convert it to meter per second. Let's say rounds a curve of radius. We have the radius of the circular track or curve 2 times to the 10 to the power 2 meters. I can say 200 meters. Instead of 2 times 10 to the 2 meters, you can say 200 meters. So find the following. A, the centripetal acceleration of the car. We look for centripetal acceleration of the car by means of these information. What are the information actually? Fg is given, Ft, but you have to convert this unit into the meter per second. How do you convert kilometers per hour in, let's say, meter per second? Just multiply the number by this ratio. So this is a conversion ratio. Whenever you want to convert kilometers per hour to meter per second, you have to use this ratio. Teacher, how do you multiply this number by this ratio? Put a denominator of 1 for 50. So numerator multiplied by numerator, denominator by denominator. 50 multiplied by 5, 250 divided by 18. And you get the number, actually, this number. This is the VT, the last result, actually. R is equal to 200 meter. Teacher, why did you turn it to 100 meter? No problem. You can write 2 times 10 to the power 2, as you like. If you are not satisfied with this number, you can say, teacher, 2 times 10 to the power 2 meter. It's the same, right? So we look for AC. AC is equal to VT square over R. AC is equal to VT. Right, we convert kilometers per hour to meter per second. 13.88 squared divided by 200, and the answer is 0.96 meter per second squared. That's it. Right. The second part of the question. Let me read the second part of the question, but I need the figure. Actually, I drew this figure for you. So it says, find the minimum coefficient of static friction. it's new for us. We got information about static friction or let's say, or kinetic friction in grade 11, but right now for grade 12, it's new for us. Maybe you forgot the rule in grade 11, no problem. I'll remind you. I'll jog your memory right now. I try to make it easy for you. It says the minimum coefficient of static friction. What do we look for? Guys, we look for mu s. We look for this guy, mu s. So mu s is unknown. The minimum coefficient of static friction means mu s, mu sub s, between the tires and the road that will allow the car to round the curve safely. So how do you find mu s actually? Firstly, you have to let's say conclude that you have to deduce that the force that maintains circular track for the car is friction, Fs, right? You agree with this value actually, with this idea, right? So Fs becomes Fc. This is the condition. Fs becomes Fc. Static friction or force of friction is in charge of maintaining the car in a circular track. Mathematically, Fs is equal to Fc. Fs means force of friction. Fc means centripetal force. Right? This is the condition. Right. It says, so by means of these information, Vt, we've already found a Vt in, let's say, in part A. We converted. And we had R. AC, we've already found AC, which is equal to 0.96 rad per second squared, and we look for mu s. Here, guys, I didn't, let's say, prove the rule for you. I just, let's say, used the rule directly. I want you to memorize the rule, especially for this case. If the frictional force becomes a centripetal force, mu s becomes AC divided by AG. So AC, keep in mind that in this subject, actually, mu s becomes a ratio between two acceleration, right? If frictional force, let's say, is the centripetal force, so centripetal acceleration divided by G to find the mu s directly. Maybe you say, teacher, what's the origin of this rule? If you want to find this rule, you have to follow this condition, right? Because it's not necessary. That's why let's say I didn't prove it for you. If you use this rule, let's say, and if you open the rule of Fc, if you open the rule of Fs, and after that, you get this value. That's why it takes time, actually. It kills our time. That's why I didn't, let's say, prove it for you. Just I just wrote the direct rule. Mu s is equal to AC over AG. That's it. AC, teacher, do we have AC here? Yes, we've already found it in previous part. 0.96 divided by 9.81. Mu s is equal to 0.098. And keep in mind that mu s is unitless, right? It's dimensionless. It has no unit. Or we have another, let's say, rule. This is the simplest rule for finding mu s, right? If you use another rule, no problem. Mu s is equal to Vt squared over Rg. You can use this rule. And if you substitute the value of AC here, AC is equal to Vt squared over R, right? Let me do it for you here. Mu s is equal to, so denominator is G. Mu, let's say AC, I want you to tell me the rule of AC. AC is equal to Vt squared divided by R. You see? So the second rule comes from this rule. If you memorize this rule, This is the main rule for finding mu s. You can, let's say, find another form of mu s. Vt square over Rg, Vt 13.88 meter per second square divided by R200 and G 9.81, and you get the same number, right? That's it, guys, for today. I want you to follow our videos in next, let's say, lectures, in next lessons, and bye for now.